In the present video, I'm going to show you some examples of probability calculations using snippets in Math Studio. We'll start by going to my YouTube website, and in there, under video 517, and also under the information for this present video, we're going to find these links. These 3 snippets are available for you. What you have to do is click on each one of them, get the download button there, save the file, and then repeat for the second file, download, save, and for the third file, click download and save. When we have that done, in our downloads folder, you're going to have those 3 files. What you have to do is open another file browser or file explorer. Sorry, this one right here. What we're going to find in this PC, under this PC, the C device, and we're going to find on the program files and Math Studio. Double click on that, open the snippets folder, and what we want to do is select, holding the shift key here, and drag these 3 files into here. They're going to ask you to provide administrator permission. You have to click that 3 times, and now you have those 3 new files in your snippets folder, and we're ready to use those snippets. I have this Math Studio file, and the first is for those examples of probability calculations. The first step is insert the snippets, 2 of them. I'm going to show you which one. So we click here and go to Tools, Snippet Manager, and we find the S&G information and insert that one. And then we type here S&G information. That means statistics and graphics information. And then we click slightly below that, and we go for Tools, Snippet Manager, and go for the S&G functions. Those are the only 2 we need. So we type S&G, I'm sorry, I get back up here, functions. The S&G information, if you open it up, we tell you some of the available functions, some of the available function part 2. We cover some of those in previous videos. We're going to look for this one, probability distribution, specifically here, probability calculations. And it will give you information on what to do. First, you have to define your PDF or PMF. That's the probability mass function, the probability density function, and a cumulative distribution function. You can use the functions from the statistics tool. Make sure that they give the names fx and upper f of x and nothing else. And then we're going to use prob D for discrete distribution and prob C for continuous distributions with arguments that are text. There are strings of characters like these with several possibilities for the intervals of interest. And here are some examples that you can try. So I close that S&G information. The functions that will produce those calculations are available in here. If you want to see the details, there will be like functions prob D and prob C for probability calculations. You can scroll down and look at them. I'm going to close this here, go up and close the SG functions, and proceed to our examples. We're going to start with a binomial distribution, which is a discrete type of distribution with parameters n and p. N is the number of repetitions, p is the probability of a single repetition. And what we do is define this function. This is as simple as typing, I'm going to type it over here, f of x, spacebar, colon, and then we go into fx, either in the all or in the matrix and vectors. We find PDF, and binomial. PDF binomial with 3 arguments, insert, and then we put x, n, and p. And that way we define the PDF by a similar token. You can define the f of x, the cumulative distribution function. You can do it like this: f of x colon equal CDF dot binomial parenthesis x and p. Okay, so those are the two definitions that we created there. I'm going to delete this one. And then to determine any probability, what you have to do is type prob d, that means probability for a discrete distribution. Put a double quote, space bar, and then type an interval, for example, x less than 5, and then put the equal sign, and it should give you the probability we're seeking. I'm going to try that again. If I put the equal sign here, after typing this, it gives me something like expecting a result. It turns out that you need to do calculations, auto calculation, or recalculate to proceed with the auto calculations. I have a number of examples in here. I'm just going to go clicking to the right and put in the equal sign. X equals 5, x less than 5, less than or equal, less than, greater than or equal. If you want an interval between 3 and 6, for example, here, both of them less than or equal. Here we change the first relationship to a less than. Here we change the second relationship to a less than. And here both less than. If the numbers are separated by 1, then a probability like this will be the sum of the probability mass function of both. In here, basically means only the value of 5 is included. In here, only the value of 4 is included. And in here, the probability is 0 because basically there's no numbers between 4 and 5 for integer probabilities, for discrete probabilities. Here's the Poisson distribution. I define my probability mass function or probability density function and my cumulative distribution function. And basically I use the same numbers as above, the same probability requirements, and it gives you the different values in here. The uniform discrete, basically you have to redefine your lowercase and uppercase f of x, and then proceed to type your probability distributions. For continuous distributions, I'm using as an example the normal right here, and I'm going to say, for example, for x equal 120, there is no functional probability for continuous distributions. And it turns out that if you include or not include the equal sign in the less than or greater than, it won't make any difference. And so you can see that all these 4 intervals represent the same probability because the extremes of the interval are not included because of the reason that a point probability is equal to 0. In here, I tried the exponential distribution and calculate only 4 probabilities. X equals 4 is always 0, less than or equal to 4 is the same as less than, x greater than is the same as greater than or equal, and this would be any of these intervals possibilities will be the same. And here's an example with the uniform distribution. You can check it out and repeat these calculations. The Weibull distribution, we have a problem there because the PDF is actually not defined. They say it is defined, but it's not available. But it doesn't matter because all these probabilities use the cumulative distribution. And so you can calculate the probabilities even though the PDF is not defined. Finally, I have one more case where I use this distribution that is not defined in the plugin for statistical tools. Is the triangular distribution. I found this in Wikipedia. And this is the graph of the typical distribution with parameters A, C, and B, C between A and B. And these are the expressions for the probability density function and the probability cumulative distribution function. And this can be implemented with a series of if statements. So x less than A here means if x is less than A, the value is 0. Else, if A is less than or equal to x less than C, it is written as A less than or equal to x and x less than C, and that value should be 2x minus A divided by B minus A. And so I go implementing all the ifs until the very last case where the case is 0. And for this one, implement the more limited number of options in here. And so in this case, the probability density function and the cumulative distribution functions are not given in the plugin, in the statistical tool plugin, but it will define the probabilities. And then after we have defined as f of x and uppercase f of x, you can use prop C to calculate probabilities of a continuous distribution. I plotted the f of x and f of x using these definitions for the triangular distribution. Just to give you an idea how to type one of these functions, I'm going to do Control C, Control V to copy here, and then I'm going to show you how to type this. You type f, parenthesis x, spacebar, colon, and then we go for the if. Click on the if here, and you say x less than or equal to a is equal to 0, else, and then we put another if there. And then this if requires us to type, a less than x, and then we go for the Boolean palette and use the and, which is this one. And that, I made a mistake here. There should be a lowercase x. And then you get immediately these parentheses, and then in the next one you have x less than or equal to c, and then the expression here will be x minus a, spacebar, raised to the square, spacebar divided by parenthesis b minus a, spacebar times parenthesis c minus a, and then we go for the next if parenthesis c less than x, then move to the right and go for the and then we have x less than b. We don't need to type the parentheses, they are typed by themselves. And then the expression here is 1 minus b minus x, spacebar, square, spacebar divided by parenthesis b minus a, square, spacebar times b minus c, else 1. And that's how you type a conditional type of functions, which were given originally by this expression, and then it's redefined in this manner. With this, we conclude this particular video on examples of probability calculations using snippets in